Good morning, folks. I think core is maybe wrapping up now. Might be a little bit. All right, maybe we should get going though. Oh, there we go. We're starting to get core people. Good morning, Laura.
Morning.
Laura, we talked a little while ago about making sure you could get hardware for doing the testing that you need to do. Just realized this morning that I haven't checked in for a while. Are you okay? Do you have stuff, or do we still need to get you stuff?
I'd still need to get stuff. I was wondering if I was gonna bring it up today. So what you're doing for your blog post, I wasn't sure if there was something that could intersect there, um,
Yeah,
or if
maybe.
not, because that might be a good way to, add to your blog post and then,
Yeah,
um, but also like, yeah, I wanted to ask you about that, what you thought.
Y- Yeah. So the reason I mentioned it yesterday, it was actually kind of like a completely accidental thing, is that when was doing tests on our NVMe cluster with like a bunch of drives, um, I saw that when I first was doing the tests, I was only using a pool with 1,000 PGs for RBD, and when I bumped that up to significantly more, we went from like 2 million random redives to like 4.4 million. So it was like a huge increase. Um, so I want to document for people that that was, such an improvement. But I'm also disabling both the balancer and the autoscaler, just because it causes so much variation when you're doing the writes. You end up like, causing a lot of topology changes. So I think what I want to do is go back and try to look at whether or not that was caused by lock contention, PG lock contention or not. That might
Mm.
help give us a clue whether or not, at like what point that matters and what point it doesn't, and like when the balancer might help and when it might not, right? Because if the balancer can make everything like super equal for reads, then that might like solve everything. But if it's more PG lock contention, then the balancer won't help as much. Um, and that's when I was thinking of kind of just like handing it over to you to showcase what like the primary read balancer work is doing. But what do you think? Like, is this the test case that you want to like showcase, or do you want to look at like other scenarios besides that?
Yeah, yeah, I think it's hard to say, but I think that would both be really valuable. So the test case I was more looking at was like a very simple small cluster setup with just to see the basic change in performance with the on an unbalanced scenario before and after the read
Yeah,
performance. But however, what you're describing is also valuable. So I would be happy to be involved, either way
yeah.
in whatever you're doing.
Like there's a really good chance that unless you're running on like crazy high performance stuff like this cluster is, the PG lock condition might not matter, right? Like then you might be dominated by the distribution quality where
Mm.
the primary read balancer helps. Um, but in this case, it might be that we're more dominated by PG lock contention, where like then you just need lots of PGs to make it happy. Um,
Right.
we'll see. Yeah, I'm not sure. Um, so I guess my question for you then would be, maybe we still need to get you hardware so that you can showcase the small scale test. And then this is like a much bigger, more complicated like thing, right?
I think so, yeah, but I would if you get to that point where you're need the balancer involvement, let me know. And if you want to set up a meeting, and I can show you how that works and everything. And I can also be involved in that as well. But I
Sure,
think, yeah, I think two separate things would work the best, I think.
Uh,
sure. And
Mark, also, again, you talked about the high performance and the PG lock. I think in order to show how the balancer, the efficiency of the balancer, it's best to work on non-performant clusters. So if we could do it, for example, on HDDs, it would be best, because then for sure the contention would be on the IOs, and we can show the
yeah,
balancer before
e-
this.
exactly. So when Laura and I were talking yesterday, the whole reason this came up is because I'm doing high performance tests, and I saw in those tests that increasing the PG count for the RBD pool above our recommendations actually resulted in a really big performance gain for random reads. Like, I don't know why
Yeah.
yet. I haven't investigated, but I suspect it's a mix of both the quality of the distribution and it's also possibly PG lock contention.
For the reads, my experience tells me that, and I don't know what were the numbers that you played with, but every time that you double the number of the PGs, the distribution, the quality of the distribution, it's like it's half. Like if you got 80% of the best performance because of distributions of read, after you double, you get around 90%. So the difference between the what you have and 100
Yeah,
is half every time you double. It's not a math. It's just I played with it a lot, and it's approximately what happens. So if you
yeah,
add more and more, you also increase the redistribution for sure. You improve the quality for sure.
exactly. I've seen very much the same thing, Josh. Um, so in this scenario, with 60 OSDs and 3x replication, uh, using 1,000 PGs in the RBD pool, which I don't remember exactly what that is. It's pretty low. It's like 20 PGs per OSD or something, I guess. I don't know. That yielded about 2 million random read IOPS. And I don't remember what it was on the right side. But when we jumped up to 16,000 PGs in that pool, which is like a kind of really big, right? Like
Yes.
probably unnecessarily big, but just to verify that we had a really good distribution. Then it was about 4.4 million IOPS, so it was over twice as fast. And I suspect that we can probably get most of that even with a smaller PG count. Um, but I haven't tested it yet. I just kind of used a really big number to verify that like we could get close to maximum.
Now, for 1,000, it's a probably some of this goes to the fact that it's better distribution, but I would say my guess is that more than 50% of the improvement relates to locks
That's kind of what
because
I'm thinking too. Yep.
yeah,
Yep.
because 1,000 gives you pretty good. I got for 1,000 I got something like uh, for 1,000 PGs on smaller clusters, but with 1,000 PGs I got something like if I remember correctly, between 20 and 40% decrease. So you can't double when you have 80%. You can't double just by the distribution. So I guess it's a combination of locks, but it makes a lot of sense that you have more locks if you have really high performance systems.
Yeah.
So
Yeah.
more lock contention. It really makes sense. So again, so if you want um, to neutralize the effect of locks, it's better to work on slower systems, and then
Yeah.
we will see the IO dominates the performance.
So we're kind of like reversing the order of this meeting, having the discussion before the PRs. But one thing that I really want to do, Seth, is I really want to make it so that we can handle more PGs per OSD by default, especially for smaller clusters. And I think that that's actually good for the balancer because I think it means that you guys have more uh, leeway. You have more PGs to play with, where you can kind of figure out how you want to schedule the topology changes in the cluster, since they're so impactful. Um, I see it as complementary personally, even though it might mean that the PG balancer is kind of playing a little bit more of a background role. I think it actually is better overall and gives the PG balancer more kind of um, runway to play with in terms of how to like migrate things around.
It makes it more only on very small cluster, on small cluster number of OSDs. If you have enough OSDs, we have enough leeway to play with
Okay.
also with smaller numbers. But having said that, our first target is ODF, and in ODF we have really small clusters many times. So I'm not objecting to what you say. It's improving. And when I say if you have like my guess, it's something like around 16 plus OSDs and replica 3, we have enough leeway to do it even with smaller number of PGs.
Okay.
But in OSD in ODF you get 6 or 4 OSDs or really small numbers many times. So yeah, adding more PGs would improve the ultra for us, just from the balancer perspective, the ultra small. For high performance with the low contention, probably there you have good reasons for these
Yeah.
for different reasons. So that's
I would very much like to see us on small clusters be able to support thousands of PGs per OSD. And when you scale out to very large clusters that have, maybe thousands of OSDs, then we have to scale back to hundreds or, maybe even less PGs per OSD. It's that global limit that I see as being the bigger problem than the per OSD limit if we can properly manage memory and PG log lengths and that. Um, I'm hoping that then we can kind of have the balancer almost be able to kind of adapt to those scenarios where maybe for small clusters you have very high PG counts and have a not necessarily a bad default distribution, but things that the balancer can tweak very slowly to kind of not impact the cluster but make it perfect. Whereas on the big clusters, I think the balancer is actually a much bigger plays a much bigger role because we may not be able to support high per OSD PG counts.
the thing is we don't move data in the balancer. So we do things fast, not slow. So that's not a problem at all. This balancer doesn't move data, so we could do things fast. I agree with what you say, but for large cluster, we have different use case. Our use case for the large cluster is to support OSDs with different sizes. So we won't have one large OSD which becomes a weakest link in the chain and cuts the performance of all the other OSDs. We would put less reads on larger OSDs and more reads on smaller OSDs, and by this we could balance the load unevenly in terms that we move, but it's not uneven, it's unevenly from data perspective, but since smaller OSDs have smaller amount of data and approximate the same performance if it's same technology, then we could balance the load. We could actually improve the performance of clusters with different sizes of OSD.
Josh, something you said there, I want to understand it better. For the primary rebalancer, you don't end up moving any data?
No, we just change the primaries within the PG. That's the only thing we're doing.
That's the only thing you're doing. Okay, so you're not there's
We
no
assume
actual
we,
data
we
movement.
assume that the data is balanced by the capacity balancer before this. We are not moving data.
Ah, okay, I see. I didn't
If the
realize
data
that.
is not balanced, then we have a problem that we may be able to solve in future version. But the only thing that we are doing is we change the primary within each PG, we play and we tweak the primary.
That's exciting. Okay, good. Yes. So if you have a very high quality distribution, it's not going to show as much of an improvement, but that's nice that for low quality distributions you can play with it a little bit and get a better redistribution without actually
Yes.
moving data. I didn't realize that. That's fantastic.
And for the highest one, when we have good, even if we have good quality, if the OSDs are on different sizes, which happens over time, that you have larger devices, then we could play and move more read load to the smaller devices versus the larger devices, and then split the load more evenly across the cluster. So the OSDs with less PGs, because they're smaller, will do more reads, and OSDs with more PGs would do mainly writes and less reads, and then you could improve the performance because they get more writes because they're larger. Assuming you know per pool the read-write ratio, you could play with the number and make sure that if you have smaller OSDs, they're doing a bit more reads. You have larger, they're doing a bit less reads, and the IOPS, in terms of IOPS, are split evenly. Because today,
Josh,
if you have one OSD of 1 terabyte and another of 2 terabyte, the one with 2 terabyte get twice the load. So it becomes full. It becomes it gets to its max bandwidth first, and the other one is doing half of its bandwidth. Because
yeah.
if you change the reads and you say, okay, the smaller one is doing more reads, you could get more performance from both of them because they will get to max bandwidth or max IOPS at the same time.
Yeah.
That's for the future. That's for the next version, not for the first version. But that's the idea, and we could do it because our operation, changing the primary, is very cheap. We don't do anything. We change meta. We add upmap record. We don't change anything. We don't not moving data, so we could play with it really easily.
Well, this is very exciting, guys. So now that you've convinced me that if I'm doing these other tests, I should definitely be also running a test with the upmap balancer because it doesn't move data. It sounds like it's only, probably only a win. So we should absolutely showcase that. Of course, it will probably show less improvement as the PG count increases, but if it can help at the low PG counts, that's interesting.
Totally. I totally agree with you.
Yeah. All right. I suspect I'm not going to get to that until after Cephalicon. I've got like 3 other articles I'm trying to write before that, and I'm theoretically going on vacation, so we'll see how it goes. But Laura, it looks like you're presenting at Cephalicon. Hardware to get your test done.
Yeah, what I'm thinking is I would ideally like to get those results into the Cephalicon presentation, but if not, I can also put it into a blog post, later and link to that in my presentation. Okay. So
if you can give me instructions on how to set the primary read balancing, I could probably get some tests done on Mako. It's not hard drives; it'd just be NVMe, a big NVMe cluster. And I know it's kind of like ridiculous doing it in the wrong order compared to what would be the better tests on hard drives. But I could probably knock those out without and get you the data, and then just hand it off to you to like deal with. Because my bottleneck right now is I've got like 20 gigs of data from the tests I've been running, and I'm trying to go through it all right now before Cephalicon, and it's like that's what I'm bogging down on. Not to mention other things I'm working on, but I think I could probably get you stuff. It'd just be probably a lot of putzing around trying to look through it all and analyze what it means.
That'd be awesome, and totally leave analysis to me. So
okay,
that would help out a ton.
Can you just give me instructions on what to do, and then I can make it happen?
Yes. Yeah, so
okay.
it's just in the I don't want to take up the whole meeting here, but it's just the OSD map tool. It's an offline version right now, so it's the same as like running. It's similar as running the upmap on the OSD map tool, and then applying the Ceph commands that are generated from that to the cluster. So I'll send you the instructions.
And is it based? Does it need data, or is it just based on PG distributions?
Just based on PG distributions, right, Josh?
Yeah. It needs a file that you generate as for OSD map tool. It gets a file of the class crash map, but you get it. Yeah, it's the same thing. nothing more than this. So you
So,
generate a file and run it. It's very easy.
so in CBT, usually the process is that we create the cluster, we create the pools, we pre-fill the pools with, or create RBD images or whatever, pre-fill the RBD images with data, and then we run the tests. Where would you want in that process the upmap balancer to sit?
I'll tell you, we have a way to evaluate how good the distribution is. We have a score for this. So we would like to run the score on the pools that you have, see the pool that is less balanced than the others. Then once you run this test, apply the balancer and balance it and run the test again. So on one pool, run the test again so we could compare the results.
So we
And
create
if
the
we could
pool.
select the pool, it's good. If we can't select the pool, then the pool that you have.
Yeah. So say we create an RBD pool. Now we've got that. Its health is okay and everything. Now, do we need to take the OSDs offline, or can we just run this tool?
No. Totally
Okay.
online, nothing to do offline.
Perfect.
The thing is that if by chance the distribution is really, really good because it's large or anything, we would see when you run the offline tool, the OSD map tool, you would see the scores. If the score was good and it's not improving a lot, we could even skip the other one because we know that it's already almost perfect. But if we
Sure.
see that we have the score, we can improve, then we run the second test and we show that we have the improvement as we expected.
Okay. So I think in CBT then, as a condition after the pool is created and found to be healthy, then we just add in whatever code is necessary for doing the upmap, primary read upmap balancing. Does that sound right?
So I would like to first that you run a test, then apply the balancing, then run the same test again. So we could do a comparison. That would be the flow.
Sure. Okay, let's talk about it offline. But I might be able to get
I'll
that
send you
in.
all the details.
Thank you. Awesome.
Thanks so much, Mark.
Yes,
Thanks.
and we'll still try to get you an insert a node with hard drives to test on. I'm also looking for one now as well because I've got a separate PR that we could talk about here. Which maybe this is the good segue into actually talking about PRs. So all right, good talk on that. This is actually quite exciting. All right, so new PRs this week. What I have, one is just a doc change for talking about PG autoscaling, in fact. And Anthony has reviewed that. That looks good. One of the comments I made in there, Casey, is it'd be really, really nice, just not as a requirement, but just if there's any possibility in the future somehow we could reduce the number of RGW pools for like all of this like metadata, it'd be really, really nice in certain ways. I don't know if that's not like something you guys have talked about or not, but there's just a lot of RGW pools.
We haven't really discussed it since we added support for the namespacing, which was several releases back. We could talk about combining some into namespaces of the same pool. But I tend to think that at least 3 for the index, the object data, and then the metadata
Correct. Yeah,
would be the
agreed.
minimum. I'll look through the metadata pools and see if any of those would make sense to combine.
Yeah, that's exactly what I was thinking too. Index data and metadata. It's not a big deal, right? I mean, it's not the end of the world the way it is now. It's just like extra complexity. But the discussion there was basically people don't seem to know like which pools need how many PGs. So, that might be a way to make it a little easier in terms of, okay, the data in the index pools need a lot, and then this metadata pool doesn't really need very many. And maybe we can actually claw back some PGs that way for the metadata pool. So okay, there's that PR, and Anthony gave lots of feedback on that. The only other PR that was new that I saw was the one that I've made here. So this is an experimental PR to add. That's not exactly add delay, but it's to basically in the KV sync thread wait until we have a certain amount of time has passed, or we have a certain number of items in the KV queue to before we actually do like a sync. And the goal with this is to see on hard drives whether or not that improves performance and latency by reducing the number of fdata syncs that we do. For hard drives, that would translate to head movement. For slower NVMe drives without power loss protection, maybe reducing the number of flushes that we do from cache to the disk or to the cells. So it's not a guaranteed win. It's experimental. I think both Adam and Igor expressed some concerns with doing it this way, which are valid. But if it does something useful, maybe it opens the door to more discussion about whether or not we want to try to implement some method of batching more metadata syncs into one transaction. Oh, thank you, Casey. I appreciate it. That's nice. Not a high priority, right? But yeah, it could be kind of a nice complexity reduction. Okay, closed PRs. It looks like, Laura, you merged Adam's harmonize log read and write modes PR. Looks like it passed stuff okay.
Yeah, I think that's the one we talked about last week, right? I got put into testing and it looked good to me.
Cool. And then the other closed PR I saw this week was for RocksDB Store, Igor's PR to use bounded iterators and RM range keys, and Yuri merged that. Igor, was there anything new on that, or did it just get through testing?
No, I think it's just past testing, that's all.
Perfect. That's exciting. Is that one, Igor, that are we backporting that, do you know?
Yeah, I submitted Quincy and Pacific backports. I'm not sure about Reef. Well, generally the question, what our current policy on Reef branch? Are we allowed to do backporting or we wait something?
Let's see, we don't have Josh here. I mean, I would say yes, we should backport that to Reef now. But that's just my take.
So we are not under code freeze for Reef at the moment.
Well, we are, but I guess the question would be whether or not this is considered a fix.
Bug fixes
we
and
backport
performance fixes
anyway.
are fixes.
What was that? Sorry?
It's a performance fix, right?
It lists fix is it's fixing a tracker ticket.
Yeah, it's related to performance indeed.
Not a new feature. Well, I'll let someone in charge of things decide that, I guess. But I think you should submit a backport request for it, and then someone can decide if it's valid or not. That would be my vote. Especially if we're backporting to Quincy and Pacific. It would seem crazy not to also backport to Reef.
Yeah, that's true, but I'm curious about code freeze policy. So
Yeah, I
What would
the feeling I've gotten over the years is that that policy is not always like set in stone
oh,
perfectly. So,
that's true.
all right. Well, yeah, exciting, Igor. I think it's good. Uh, that's a good fix. All right. Next, we've got a couple of updated PRs here. Igor, another one from you for your improving fragmentation by overriding rockcb writable file allocate. I think is that you just had new updates for that? Is that right?
No, I believe it's just a single liner, so nothing to update there.
Okay. Just a very minor fix. Um, Adam's approved that. Do we just need that to go through QA now?
I think so.
Okay, I'm gonna just throw the. Oh, it does have needs QA on it perfectly. Perfect. Okay. Uh, I'll just note that here. Needs QA. Okay. Next. The Ceph volume PR for improving the performance when using dmcrypt. So Joshua, I saw you added the comment regarding splitting that. Good deal. I think that's the only update we have right now. So we'll see if the author does that or what they want to do going forward. Next, performance testing for Crimson with CBT in Teuthology. I apparently have approved that. I think there were some more updates. I heard Matan mention he was working on it this morning during stand-up. So I don't know exactly what the state of that is, but it's still being updated, still being worked on. Next, we have enabling TC malloc while using CStar and Crimson. The good news here is that Radek has been working on adding the necessary bypasses in ASAN, similar to what we do for Valgrind. And it looks like that's making everything pass properly. So that's in PR 5598. And once that's merged, we could either do this as part of that PR, add the CCMalloc thing into that, or just get that merged first and then merge the TCMalloc PR. Doesn't really matter to me either way. But the good news is that it looks like there's a light at the end of the tunnel here toward getting TCMalloc enabled for Crimson, and thus making the Blue Store performance in Crimson much, much better. Okay, and then the last thing here is for C-Store adding a fine-grained cache. There were some benchmarks included in that, and it got a new review. So that's actively being worked on. And that was it for new, closed, and updated PRs that I saw. Anything I missed from anyone? All right. So we already had our discussion topic, I think, on primary rebalancing, which was very good. I had a couple of other small ones here, but maybe before I get into those, since they're small, would anyone have anything they'd want to bring up this week or talk about this week? All right, then I will plow ahead with the couple I have here. So I mentioned this PR for trying to implement waiting in the KV-sync thread to try to accumulate more operations in a single transaction for the Blue Store Red Hat log. Adam and Igor, we talked about this earlier this week. it may not be the way we want to go in the long run for doing this kind of thing, but just for the community at large here. What I recently I had a user that was trying to run BlueStore on just pure hard drive setups, and it was pretty slow and completely seek bound on the hard drives. And so I kind of suspected that maybe if we tried to reduce the amount of seeks that we saw going between the write-ahead log and writing data out in other portions of the disk, that we might be able to see a performance gain. I'm not sure this actually works because we'll still be doing F data sync for every object write, and maybe we won't be able to really batch things up the way I'm hoping here. But I figured this was maybe a really low-hanging fruit way to just see if we see any gain by trying to batch transactions together, or batch multiple ops into one transaction rather. Yeah. Does anyone have any thoughts on this before I run off to try it on hard drive somewhere? Igor, I know you had commented earlier that you weren't sure whether or not doing this in the KV sync thread was the right place. A different option might be. Oh, go ahead.
Well, my initial thinking was about the third write, so I wanted to move it out of KV sync thread then. But as far as I understand now, you are trying to match all requests, all KV transactions, so that command doesn't matter anymore.
We could try to populate the queue in a way that we only shove stuff into it from a higher level if we were satisfied that we had enough work for the KV sync thread to do. It'd be a little different, right?
I don't know, honestly.
I think personally I like it better in the KV sync thread itself than to do it that way.
Well, if it's intended to match everything, then much sense if it's done it KV sync thread or out of it. I don't know, but well, I would suggest to try this approach first and then decide.
Yeah, I think that's really just the next step, is to see if any of this even makes sense. The one interesting bit in this PR that I saw was that once we get to the point on NVMe drives where we're actually throttling performance and reducing IOPS a little bit, we do see tail latency go down, which I think makes sense, right? Like that doesn't seem unreasonable to me. We see the average latency go up, but tail latency go down.
Yeah, maybe.
Probably not worth it though. Kind of a big IOPS hit, like 10%, just get a little bit of tail latency reduction. So there, I don't think it's worth it. I think it's better just to skip all of this for NVMe drives, or at least fast ones. For hard drives, I think the jury is still out, maybe. Well, we'll see. Kind of fun, but it's a very specific kind of thing for people that are running on hard drives with no flash. We've discouraged it for a long time, so this is kind of just a low-hanging fruit kind of thing. If we can do it easily, maybe we make it better, but otherwise, maybe not a big focus for us.
Well, I don't think it's only for guys that running it on hard drives. since the same effect it would be on any deployment that data sync latency would be similar for both main device and DB device. So if you have situation like this, really it could be profitable to craft a mechanism to squeeze more operations per one fdata sync to main device per one fdata sync to DB device. So while I don't really like that crude just make a sleep, and I'm dreaming on some better control, just picking on maybe what we have already in queue or something like that. I'm using a dreaming deliberately here. But I see that some control over the process could get us some performance in more cases than only HDDs.
Adam,
Of
if it
course,
makes you
HDDs are just like obvious because there are tens of milliseconds
yeah,
each time you get fdata sync.
Adam, if it makes you feel better, I didn't actually implement a sleep. It just loops until you are either past your time window or have enough operations coalesced in the queue.
But
Slightly
there,
different.
I might remember wrongly, but there was no picking if there is anything still pending to be executed.
It just looks at the size of the queue or the duration of time that's passed. That's the only parameters that if either of those conditions are set such that you don't have enough items or not enough time has passed, then it just loops and skips.
Okay, so single op running in will cause it to spin for longer than it should.
Yeah, potentially, or at least spin until it's hit a certain time limit, and then just. Um, but it's interesting because we already have some mechanism to sleep the KV sync thread, so it's interacting with that in some fashion. Like once you have an item in the queue, I think the thread wakes up, it starts spinning, and then it will either time out, merge, do the operation, do the transaction, or it will accumulate enough IOs to do it, and then assuming that the queue is empty again after that, then I guess it probably goes to sleep. I don't know exactly what does that, but there's some code somewhere, I guess, that tells the thread to go back to sleep at some point.
Okay, and anyway, I do intend to check that independently. I asked to upgrade Inserta 7 to CentOS 8 so I could compile main without hiccups.
Please do, because I'd like to have a second set of eyes on this too, not just mine, to see if this is a good idea or just awful. Um, if necessary, I don't know how hard it is to do these upgrades. It looked like David Galloway could do it really easily. So hopefully it's not too hard. But if it's like if people can't do it, maybe I can try to help. I know that there's some kind of goofy pixie boot thing that we can do to like image things, but I don't know a lot about it.
Adam Kreitman seemed to be, let's say, a bit eager to do it. So let's wait what will be cooked from it.
Yay!
It's
Excellent.
very difficult for me, but I was happy to hear that he says it's no biggie. I mean, okay, I'm taking that.
Yay! Right? Yeah. That's fantastic news. I'm very happy to hear that. Cool. Okay, so enough about that PR. The only other thing I had to mention this week is that I've been doing a lot of testing on Reef, and I suspect that when we take away the RocksDB tuning improvements that we did in Reef, I think we have a minor regression for small random IO. at least small random writes. It's not a big one, and it's completely masked by the RocksDB tuning improvements. But without those improvements, I think we're seeing about a 5 to 6% a regression in small random write performance, and it's not being caused, as far as I can tell, by the RocksDB upgrade that we did. Something else. So don't know what it is yet. Probably need to do a bisect. Questionable whether or not the bisect is going to be able to tease out a 5% reduction. That's pretty tight, but we'll see. If I can find it, I'll try to get a fix in place before Reef. No guarantees there, though. Having said that, though, Reef overall is still faster than Quincy was with the other improvements. So, overall, we're still looking good. Just as a minor thing that we maybe want to try to track down if we can. And I think, guys, that's all I had. So, one more time, I'll open it up. Anyone have anything they want to discuss this week before we wrap up?
Nothing more
All
for
right.
me. Just that I'll send you an email of the stuff we talked about, and an example of using the read balancer.
Cool. Thanks, Laura. And then, yeah, we need to get you on one of the inserted nodes too, I think. Let me talk to Sam, or I don't know who exactly we should talk to about. We've got like 4 inserted nodes in the Jenkins queue for doing Crimson continuous integration performance tests. And I'm pretty sure that like only one of those nodes ever gets really used effectively. So the other 3 might just be kind of sitting there. And if that's the case, we should just start using for development again. There's no reason to waste those resources if people can be using them for this kind of thing. So I'll try to dig into that and find out what's going on. So yes, yeah.
Thanks.
Cool. All right. Well, I think that's it, guys. Thanks for coming. Have a great week. And next week we may be on Jitsi. We'll see. Mike said that he wants to try to use us as a guinea pig for doing that before everyone else is forced to move over. So theoretically it was going to happen today, but we just kind of ran out of time. But next week I think we're going to be on Jitsi. So I'll send out an announcement and we'll see how it goes. Thanks, everyone.
Bye, Mark. Thanks.
Bye. Yes, Adam. Guinea pigs are great. Bye, everyone.